Hi everyone, welcome back to another video on independent sample t-test, or we can call it as IST. So before introducing IST into the SPSS, we will be looking about how and when to use IST when we have a question. So now let's begin with what do you mean by IST. So it compares the mean between two unrelated groups on the same continuous dependent variable. So you will have a dependent variable and you have independent variable or the exposure variables. So the dependent variable should be in the continuous form. Always you have to remember that. So if it is in continuous form and you have two groups and the two groups are measuring the same continuous dependent variable, then we go for independent sample t-test or IST. So if the two groups were related, then we go for paired t-test. So the video on the paired t-test will be coming soon. So here we have two unrelated groups. So when it is unrelated, we have IST. So what are the examples of IST? So when we have two drug A and drug B, and both the drug are used to see whether the testosterone levels are increasing or not. So the testosterone levels are measured in the continuous variable. So we have that as the dependent variable, and we have the two groups as drug A and drug B. So all the patients will be there in drug A and drug B, and we will be analyzing them to check whether whose testosterone levels have increased. So based upon our hypothesis, we can fix the tails. So we have left tail, we have right tail, we have two tails. To two tail means we will be fixing like our null hypothesis will be our drug A and drug B will be same as effective, and our alternative will be in the both direction. That is, it can be either drug A more effective or drug B more effective, drug A less effective than drug B. Like that we can fix in any direction. So directions is said about the tail. So the right tail is the drug A can increase more testosterone levels in males than drug B. That is, we can say as mu. Mu is for the mean, we are saying, or so we can say it as mu1 for drug A and mu2 for drug B. So mu1 will be greater than mu2 or mu2 for drug B. In this case, this will be my alternative hypothesis. So always my null hypothesis will be mu1 equal to mu2. That is, both the drugs are same as effective. So the alternative will be right-tailed or left-tailed, or it can be a two-tailed. So when we so how to calculate this in the IST in the normal form, and we have two equations for that. One is when population variance is unknown and there is no situations of our population variance of being same. So in that case, we have t is equal to x1 bar minus x2 bar by square root of s1 square by n1 plus s2 square by n2. x1 bar and x2 bar are the mean of the first group and the second group. s1 and s2 are the standard deviations for the both two groups, and n1 and n2 are the sample size. So when our population variance is assumed to be same but it is unknown, we have t is equal to x1 bar minus x2 bar by square root of n1 minus 1 s1 square plus n2 minus 1 s2 square by n1 plus n2 minus 2 the whole into 1 by n1 plus 1 by n2. So these are the two equations that are used in IST. Always remember, here the population variance is unknown. When the population variance is known, we go for z-test instead of IST. So here we have t-test because we have two groups and both the groups are unrelated and the population variance is unknown. So there are some assumptions about IST. When we are using IST, these assumptions should be met, then only we can use this IST. So first assumption is that the dependent variable should be measured on the continuous scale. We have already seen that. Second is independent variable should be consisting of two categorical groups. So it should be of two groups. So if it is more than two groups, we go for ANOVA. If only for two groups, we go for t-test. So third assumption is independence of observations. The observation should not be related. So fourth is there is no significant outliers, because outliers cause some problems in our calculation, so there should be no significant outliers. Fifth is that dependent variable should approximately normally distributed. So this is a great important assumption that should be met, that is, it should be normally distributed. Otherwise we can go for IST, we have to go for non-parametric if this assumption is not met. So sixth is homogeneity of variance, that is the variance should be same for the two groups in the population. So these are the 6 assumptions that should be met before we are going for IST. So now let's look how to do this IST on SPSS. Right, let us begin in SPSS. So here I have a master sheet. So as you can see, I have one nominal data and a category and a numerical data. So this is in a continuous type. So here you can see I have drug as my nominal data. So there are two groups, drug A and drug B are the two groups, and here I have the dependent variable as in a continuous form, which is testosterone levels. So yeah, here I have testosterone levels as my dependent variable, which is in continuous scale. So scaling you can give here, so scale. So nominal drug I have given as labels, I have given as 1 for A and 2 as B. So I have two drugs, and here I have one dependent variable which is in continuous form. So the first thing is we have to make sure this dependent variable follows normality. So I'm going to check the normality. So you can go for analyze descriptive explore. Here you can check for normality. I'm giving this as dependent variable. I have to check for normality, outliers also. So outliers, here I have given histogram with normality plots, so it shows whether it follows normality or not on a histogram. So then I click on OK, and here we will have a descriptive statistics of the variable that we are measuring, and then we have a the outliers, extreme values. From here we are checking the outliers. So here we have the descriptives, we have the mean, median, mode, so the 5 summaries. So here we have extreme values. So the extreme values 78, 77, which is the highest. So you can see that there is no outliers here, so it's almost okay. So outliers condition is met. So normality, that's condition for normality. Here test for normality mine 0.2, so it shows it's not significant, which means it follows normality. So here I have normality. Here maybe this can be an outlier, even though it shows by the Kolmogorov-Smirnov test and Shapovalov test, it shows it follows normality because this is greater than 0.05. So we have that, we have the box plot and the QQ plot. So QQ plot, yeah, the points are lying along the diagonal line, so yeah, it follows normality. So even though there is some this whisker is going a little bit down, I'm calling for normality, because here the two tests are saying it follows normality. So here next thing is we will directly go for IST first. We have, after we have checked the normality, so here this follows normality and we have two groups. Now we are going for IST. So here you have analyze, you have compare means, you have independent sample t-test. On the grouping variable you have to give the name of the nominal data you have, all the groups you have taken, and you have to define those groups. You have to give the numbers, labels for those, and on the test variable you can give the dependent variable options. There is nothing to worry if you are following 95% confidence level. So if you're for 99, you can give 99 here, and then you can click on OK, and your IST table will be provided. So here this is just a descriptive of the two drugs and their testosterone levels. Here you have Lebanese test for equality of variance, which check our assumption of homogeneity of variance. Here I have as non-significant, which means both the groups have almost equal variance, so that is also measured, or also it is correct in this case. So we have to take the testosterone levels in equal variance assumed, so this conditions is also met. So here we have for the two tail 0.071, which means as non-significant, which comes turn that both the drugs, drug A and drug B, have the same testosterone levels, or the mean testosterone levels for the drug A and drug B are almost same. So because this is not significant, so you have the 95% confidence level for the mean difference. So mean difference is 5.313. So that's why maybe our two drugs are almost same. Here you have the t value, and here you have the degrees of freedom. Sigma 2 tail is your p value. Okay, so that's all for IST. So I hope that you have understand how and when to apply IST and how to do in SPSS. So if you have any doubt, you can just comment below, so I'll be giving all the answers for it out. So if you like this video, please hit the like button and also the subscribe button, so that for any other videos that will be uploaded by me in the nearby future, you will get an instant notification. So thank you and bye bye.